what do we know about triangles?
That they can
They-
be right,
They
left.
have three sides.
Wait, no, right.
Three sides, okay, so I want you to draw a triangle that's ABC. And I don't care how your triangle looks, mine's gonna look like this.
Is it
I'm making one right.
And I want you to draw ABC as your triangle. So you're gonna put it, remember the vertices are how we name a triangle, right? Okay, now I want you to try to draw the exact same triangle right next to it, right over here.
Same size.
Same size, same everything.
So it's 4
Now, obviously, this is kind of hard to do. And let's call this one JKL. Okay? Everybody good there?
Yeah.
Now again, yours don't have to necessarily look like mine, but. So again, how would I name this triangle? I'm gonna name this triangle by writing our little triangle symbol. And then the vertices, and it really doesn't matter how I write my vertices. A lot of the times, again, they do it in alphabetical order, so we're gonna call this one triangle ABC. Now, if it's congruent, what does that mean that they are?
Exactly the same.
Exactly, right? So what is exactly the same?
Means that they're the same
They're the
shape,
same
size.
The same shape and the same size. Okay? So every single corresponding part has to be congruent to something else. Okay, what's corresponding mean again?
It works together.
Okay, they go together or they're in the same spot.
Yeah.
Okay, so what's our symbol for congruent again?
Squiggly.
Equal sign with a
Equal sign
squiggly
with a
line.
squiggly.
Okay, so let's write triangle ABC, and then let's write our equal sign with our squiggly, so we're gonna say it's congruent. Now we're going to, how can I show everybody that would walk into the door right now that I want this triangle on the left to be the exact same thing as this triangle on the right?
JKL.
Triangle. JKL.
Okay, so I'm gonna write it as triangle JKL. And what is important here?
They're the same order.
Yeah, so right here, when you write this right here, the order is very important. So if you didn't do ABC, if you took a cab, then we would have to say what? If I did cab, C-A-B, I would have then had to say it's congruent to triangle what?
LJK.
LJK. Does that make sense to everybody? So you gotta go with the exact same corresponding order. Now, how do I show everybody that angle A is congruent to angle J if I don't write this?
Dashes.
Kind of, but not necessarily a dash.
A
When
box.
you put the little lines on the
The
sides.
curved lines.
An arrow.
And what do you call those curved lines? What you're thinking about
Is that
sides.
ordered pairs or?
I'm saying angles. How do you show angles are congruent to each other in my things?
Oh, the things in the corner. The arches in the corner.
The what?
Arches.
Not arches, but
Arcs.
arcs. Okay, so let's put one arc here. So we have to put one arc where? J, right? And then up on top, let's put 2. So I gotta put 2 over here. And then on the right hand side, let's put 3.
Mine's the right triangle.
Yours is a right triangle?
Yeah.
So if Jacob uses a right triangle, he's probably not using all the slashes or the arcs, sorry. You know, you got me saying it. All the arcs, he's going to put his box in the corner in one of them. So you can use the box as one of those signifiers. All right? So Grace is right, though. And to show that not only are my angles congruent to the corresponding angle, remember the corresponding means it's in the same spot, and we want to say that just in case they would have taken this second triangle and turned it upside down. So then K would have been at the bottom, but K could still be congruent to angle B. Does that make sense? And that's why you use the little arcs, or what do I call this right here?
Similarity.
Okay, but are we talking about similarity?
Congruency.
Yeah, so this, you're exactly right. It's called a congruence statement. And realistically, we could use a congruent statement to tell everybody what is congruent to each other without ever drawing a picture, right? In my congruent statement, the order, that's why the order really matters. What is in the same spot have to be congruent to each other. So angle B is congruent to angle K, and I could tell that without even drawing the angles. I could just look at my congruent statement. That's what makes sense. Or does that make sense? Okay, so from there, remember way back when we were talking about trigonometry and other triangles? We said that the angles and the sides opposite of them basically what? Work together, right? The sides, right? Opposite of it. So if I'm showing my sides that are opposite of A, that would be that side right over there. Would you agree with that?
Yeah.
And I could either call that what? What is it? Two names that I could call
Lowercase
that
a.
side.
Oh, hypotenuse.
Lowercase a.
I could call it lowercase a, or what else would I have to call it?
Hypotenuse or something.
No, because it's not the longest one.
It's not, it can't be a hypotenuse because why?
They're all the same
size.
sides, length. It's not the longest.
Why can't it be a hypotenuse in this case?
Same angle.
All sides are the same length.
I don't know that either.
Oh.
How do I definitely know that that's not a hypotenuse though? It's not a right triangle. If it's not a right triangle, I don't have hypotenuse.
I do.
Jacob drew right triangles, so he has a hypotenuse. Okay? So what else can I call this besides little a? And does everybody understand why it's little a?
Yes.
Because it's across from capital A, right? The side opposite of it goes with the angle. So what else could I call
Did we learn this already?
it? I would think we probably said this.
Opposite side.
I want you to name it though. Like Nathan. Don't name it Nathan though, obviously. So how can I name it besides lowercase a?
Junior.
Number?
Yeah, what letters?
Any letter that is
C.
What letters would I name that side?
The
lowercase.
opposite side.
Oh, AB or AC.
BC.
Why BC?
Oh
Because
wait.
it's in between those.
Because it's BC, right? So,
That's okay.
BC, the side, is congruent to what?
A, B.
KL.
KL.
Or kale.
And we really should put a line over the top. Now, don't worry about the line so much, but as of right now, we'll learn more about that in geometry when we get there. Okay? So, little a, or we could say little a is congruent to what? Little j. Alright? So, just by looking at this, and notice here, when I went back to my letters, look at BC and KL are in the same spots. So they tell me that those sides are congruent to each other because of that congruent statement. Okay? So, how then do I show the sides are congruent? I would use my what? My little slashes or dashes, right? Now, personally, I would always try, because this angle had one arc, I would make this side one slash or dash. Okay? So I'm going to put 1 to 1. And then because my capital B was 2, the side opposite, I'm going to make that 2 to 2. Does that make sense what I'm saying there?
Yeah.
And then my 3 to 3. Now Jacob's probably, he might not have it this way because he used a box. And you can't really put the box on your hypotenuse. So then he would probably have to find a different way of doing this. Now, the book, especially in our geometry book when you get there, they don't necessarily do this all the time. So they'll still use the slashes, but they're not going to necessarily match them up with the 1s and the 2s and the 3s the same way that we did the 1s, the 2s, and the 3s with the arcs.
Just as long as it isn't.
Okay, does that make sense what I'm saying? All right. So, again now, these two things right here, me drawing the angles and putting all those marks on it, and me writing this congruent statement are the exact same thing. They're telling me what is congruent in that triangle. And if all of that is true, then we can say those two triangles are congruent. And again, it does not matter how you write your first three letters. You could have done CAB, you could have done ABC, you could have done BCA, you could have done BAC. But then it does matter how you match up that second triangle. That make sense? Okay with that? So, turn to page 502, please.
502.
502. So on page 502, we have some examples, and the only reason we're going to use the book is it's a little easier to draw, so we're all on the same page. So notice here in number 3. See, in number 3 is kind of what I was talking about, is if they would take one of those triangles and rotate it around or flip it upside down or whatever they did to it. So everybody think about this. Don't say anything out loud. If they said KMJ, what would the second triangle have to be written as?
D.
You're supposed to be thinking.
Yes.
KMJ. So again, notice how they wrote their first one. They didn't go in the order of the arcs, did they? They went 1 arc, 3 arc, 2 arc. So again, it doesn't matter, and they didn't even do it in alphabetical order. So again, I'm just showing you that it can be in any different order. So if they did KMJ, what do we have to say for our second triangle? B, what? C or G?
G. G. As in
Big G.
G as in goat, right? Has to be the second letter.
Big
Yeah.
Christmas.
Not C.
They did KMJ.
Oh.
Look at it.
Christmas.
Your concentration level lately has been really bad.
So it should spell Big G
Shh.
Christmas.
All right, are we good with that? Here's a question with the next one. Grace, do you understand why it was that? Number 4. I want you to think about this. Does everybody understand what angle I'm looking at if I said ABD in number 4? How do you know what angle I'm looking at if I say ABD? What has to be in the middle? B, right? So I'm looking at where they connect on the left-hand side. Would you all agree with that?
Yes.
Okay, so here's the question. From yesterday. Don't say this out loud. Think about it. What could I call angles ABD and angles CBE from yesterday? What vocabulary word from yesterday would ABD and CBE be considered? Everybody think they got an answer?
Yeah.
What do you think?
Corresponding.
No.
Vertical.
Vertical angles. Exactly right. See how they're diagonal from each other?
Yeah.
So they're automatically what?
The same.
The same. They're congruent, right? That's what we learned yesterday. So even if they would not have put the arcs around angle B, you would have known that they were congruent because of what we've already learned. That's what you have to do next year, or sorry, in 2 years in geometry. That's what they mean by doing a proof. You're going to do those kind of things. Okay? So, Grace, because they do it as CBE, everybody think about what your triangle should be. CBE matches with what? DBA. Everybody agree?
I got it right.
Everybody understand why? Okay, number 5. Number 5, 6, 7, and 8. How do we do the problem? Well, we do the problem because they give us what? A congruent statement, right? Right above it in the directions, they tell us. So if you don't like that, just doing the congruent statement, then you have to take the time to draw your own triangles. And that's totally fine. All right? But otherwise, you can just use the congruent statement and match the letters up. So again, because C and L are in the same spots, I know that those two angles are in the same spot. So again, when you're going to do this part right here in these kind of problems, angles only have one letter, sides have two letters. Unless they would use the lowercase letter. Okay? So sides either have two letters, which are both of my vertices, or the lowercase letters. So, again, don't say it out loud, let everybody have a chance to think. In number 5, angle J is congruent to what? 6, angle A is congruent to? What do you got?
K.
JD, the side, is congruent to what side? Okay, here's the question. What if Miley says NM? Is her side still congruent to JD? Yes. So even though that we stress that the letters have to be in the same order, if you flip-flop the letters when you're talking about sides to sides, that's actually okay, because it's still representing the same side, right? It doesn't matter if I flip the side over, it's still going to be 7 compared to 7. You know what I'm saying? So, number 8, AN is congruent to, what do we get? KD, exactly right. Everybody good with all that? All right, number 9, we love story problems. A tower that supports high voltage power lines is shown at the right. In the tower, triangle ETC is congruent to triangle YRC. What is the length of RC if EC is 10 and TC is 15? Can I find out what RC is from what they gave me?
Yeah.
Because why? Because TC, they give us the same one, right? So what are we going to say? 15. So basically, them giving us EC is worthless for that problem, right? Okay?
So what's your favorite? For the answer, would you put just 15 feet, or would you put like it's, or could you put like it's equal to TC? Or would you just
Either way, that's probably fine. Well, this one, they say, what is the length? So I would put the number. Okay? All right? Questions here?
I'm sorry.
That's it.